In this video lesson, I'm going to talk about probability and lottery odds. Not long ago, I came across a newspaper article and it read, "The lottery is our best hope, say 3 in 10. That means that 30% of people think the lottery is their best hope. So in this video, I'm going to talk about how to calculate the odds of winning the lottery using two different methods. The first method is using combinations, or combination theory, I guess, of the equations. And don't be frightened away by all the numbers and the equations. I'm going to walk you through it step by step. And the second method, I'm going to use probability theory, which is the classic way. So, and again, don't freak out. I'm going to walk you through it step by step. Depending on the lottery, there's a different number of balls that they choose. And in this example, I'm going to use 49 different balls. And I will pick 6 different numbers. There are a lot of different combinations picking 6 numbers at random from 49 different balls. And that's what I'm going to do. I'm going to count up or figure out how many different combinations. So that's the first thing, how many different combinations. And we know that the numbers we picked initially, that's just one combination. So if we know we have one combination out of how many total possible combinations, these represent one combination, and the order of the numbers do not make a difference. I'm going to calculate how many different combinations. So the first thing I know is n is equal to 49. That's the total number of balls. And small case n, or green n, is equal to 6. That's how many I'm going to pick at one time. Number of balls picked. So this is my standard equation. I'm going to just plug and chug. So I take 49 factorial divided by 6, the green 6, factorial. And then I take 49, again, 49 minus, let me squeeze through there, 49 minus 6. Close the parentheses and a factorial sign. And this simplifies to 49 factorial divided by 6 factorial. I'll bring that over. And I have 49 minus 6, which is 43. I bring down the factorial sign. And I multiply that times the 6 factorial. Now I could pound this out in a calculator, but I'm going to simplify it first. You don't have to, but I'm going to show you how to simplify it. So this all equals 49. Let me make my division line long there. 49 times 48 times 47 times 46 times 45 times 44 times 43 factorial divided by 6 factorial times 43 factorial. The 43 factorials cancel. Now if I multiply out the numerator, I get 10 billion and something divided by 6 factorial, or 6 times 5 times 4 times 3 times 2 times 1, equal to 10 billion divided by 720. And this is equal to 13,983,816. That's the total number of combinations I can have with 49 balls, picking 6 at a time. So my total combinations is 13 million something. And I started out with one combination. So the chances of getting this one combination is 1 out of 13,983,816. Now I'm going to use standard probability theory. This is exactly the same as the permutations I did with marbles without replacement. So what's the probability of picking a green ball? It's total picked out of total numbers. And in this case, it's 6 out of 49. So I pick one of the numbers, one of the green ones. Now I have the probability of picking the next number is the total picked divided by total numbers. And this is what's the total pick that's left over. And it's going to be 5. So I have 1, 2, 3, 4, 5 numbers left over. And so I'm going to move that 5. That's where that 5 comes from. Out of 48. So there's 48 numbers left over too. So if I added up all those numbers, there's 48 total. So it's 5 out of 48. And I'll bring that over there, right there. Now I have the same equation again. I have total picked, total left picked out of total numbers. And I have 4 left over, right? So I have 4 out of 47. Let me bring that ball over. I have, again, the same thing over and over again. I hope you're getting the hang of it. Now I have 3 balls left, 3 green balls left. So it's 3 out of 46. Bring that over. Now I have 2 out of 45. I'm going to get there. So I have 2 out of 45. I have 2 balls left and out of 45 total balls. Let me bring that one over. So this isn't so bad. And now finally I have the last total picked out of total numbers. I have 1 ball left out of 44 possibilities. Yeah, let me bring that ball over. Now let me take all these numbers, all these fractions right there, and let's multiply them all together. I'll multiply them all times each other. And the numerator, surprisingly, is equal to 720, and the denominator is equal to that 10 billion number we came up with before. And this is equal to 1 out of 13,983,816. So it calculates the same as the previous example. And I do like it when a plan comes together and everything works out. So share the knowledge, share the love. Facebook, Google+, Twitter. Questions and comments below. And don't forget to subscribe because I'm always posting new things.